Okay, College Algebra 1.6 is about other types of equations besides quadratics and linears. Primarily, it's about rationals and radical equations. We'll start with rationals, one or more terms where a variable is rational, meaning there's a fraction with a variable somewhere in it. Most of the time, you'll have an x or some x plus or minus something in the denominator. One thing to note for something like 1 over x minus 2, the one thing we can't do in math is we can't divide by 0 for our setup. So if you have x minus 2 in the denominator, you know that x is never allowed to be 2. What that means is that if eventually you're solving this problem and you were to get x equals 2 as an answer, you get to have to throw it out because it's not defined. The function's not defined at 2. So you can't use that as an answer. So your general steps for solving are as follows. You exclude those values. So really, you don't have to write it out, but make a mental note of the things you can include. For example, here we can't include 1 because 1 minus 1 is 0 and we can't divide by that. Multiply the equation by the least common multiple of the denominators. Some people will simply choose to multiply by all the denominators. That's fine in this case. It's like the least common denominator, but the reason we do this is it clears all the fractions. So let's see what happens when we distribute the 3 and the x minus 1 to all terms. In the first fraction, the 3's cancel, so I'm left with an x minus 1 times a 3x minus 1, the numerator. In the second fraction, the x minus 1's cancel, but I'm left with a 3 and a 2x. And in the final one, there's no denominator on the right side, so everything has to be multiplied by together. So in this first set, I have to distribute. We get 3x squared minus 3x minus x plus 1. When I multiply these together, I get minus 6x. On the right side, it'll be 3x minus 3 times x, so 3x squared minus 3x. Now I have to combine like terms. This is looking quadratic because there's x squared, so I'm going to subtract 3x squareds here. What happens is these cancel. I look like I have negative 3x and negative x and negative 6x, so I have negative 10x plus 1 equals, bring down the negative 3x. This is now linear because my squared terms canceled, so I'm going to add my 10x to the other side. All I have to do is get all my x's to one side. 1 equals 7x, divided by 7, x equals 1/7. Now, you can either plug this back in and check your answer. Like we said, we made a note of the answers we can't have at the beginning. We knew we can't get 1. Since we didn't get 1, we're not that worried about our answer here, but it never hurts to plug this back in and check. I'll leave that to you if you would like to do it. Now, this was nice because it ended up linear. Sometimes it won't always end up linear, so let's look at some other problems. Okay, so sometimes your quadratic term is not going to cancel, so you've got work to do. Now, also, your denominators can be more complicated, so it will require some effort. My suggestion is to factor every denominator you can. X minus 2 can't be factored, x can't be factored, but x squared minus 2x is factored out an x times x minus 2. So when we're talking about the LCM, you have to count them. I see an x, but it's in 2 places. That doesn't mean I need 2 x's. It just means the x will cancel out in 2 places. If I had an x squared by itself factored out, then I would need an x squared. Similarly, I see 2 x minus 2's, but because they're in separate fractions, I don't need an x minus 2 squared because 1 x minus 2 will cancel out in both locations when distributed. So I need an x and an x minus 2. I'm going to multiply them in like this, because it's easier to do that into each part of the fraction. So in the first fraction, when I distribute, x minus 2's cancel, but the x and the 3x plus 2 are left. Second fraction, the x's cancel, but the 1 and the x minus 2 are left. In the last fraction, the x and the x minus 2 cancel, so the only thing that survives the multiplying is the minus 2. So then when I multiply these, I get 3x squared plus 2x plus x minus 2 equals negative 2. Okay, so combine our like terms. 3x squared plus 3x minus 2 equals negative 2. Since this is quadratic, I'm going to add 2. I set it equal to 0. Something nice happens here. 3x squared plus 3x equals 0. I can factor out a 3x times x plus 1. When I set each of these equal to 0, 3x equals 0 or x plus 1 equals 0, I either get x equals 0 or x equals negative 1. Now notice we didn't check what values we're not allowed to have at the beginning, but if I look at my least common multiple here, I know that this one can't be equal to 0, and x minus 2 can't be equal to 0, so x can't be 2. So notice that one of my answers is a bad answer because it's not in the domain. The reason for this is if I try to plug in this 0, I get 1 over 0 here, which is undefined, and actually I get negative 2 over 0 on the other side, which is undefined. But negative 1 is fine, so we have just one answer. Let's try this again one more time. Again, if I factor this, x plus 1, x minus 1, the least common multiple, I need 1x plus 1 and 1x minus 1, so this is very similar to the last problem. Now, if we want to note at the beginning, that means x can't be negative 1 and x can't be 1 because then it will be undefined. But I still need to multiply. I can still multiply by x plus 1 and x minus 1 in any other circumstance because I know if x can't be negative 1 or 1 that this is not multiplying both sides by 0. So there's a few different reasons we have to have that assurance. So the x minus 1 cancels in the first fraction, so we have x plus 1 times negative 4x. In the second fraction was the x plus 1s that cancel, so plus 4 times x minus 1. The last fraction, just the negative 8. It's a round after. When I distribute, I get negative 4x squared minus 4x plus 4x minus 4 equals negative 8. Looks like my middle terms cancel. Negative 4x squared minus 4 equals negative 8. Even though this is quadratic, because there's no x term, I can add 4 to the other side. I can use the square root rule. Negative 4x x squared equals negative 4, divide by negative 4. We get x squared equals 1. When we take the square root, that means x is equal to plus or minus 1. Now, if you move it all over to the left and factored, you get the same thing. Now, what do we note here? This means x is either 1 or x is negative 1. Now, look at this. Both of those are bad answers. What does that mean? It actually means both of our possible solutions don't work, and there is no solution here. And we will do more from 1.6 in the next video.